In this video, we are going to start writing inequalities that represent real-life situations. So we're going to have to start with a word bank and understand what words represent what inequalities. At the very end of the video, we are going to revisit studying what the definition of an inequality is, what is a solution, and determine whether a value is a solution. So first and foremost, we have to have a list of things and words that represent these inequalities. Our four inequality symbols that we're focused on are these four symbols here. So what I want us to do is just write down what they represent. For example, this one, when it points to the right, we are always assuming in these cases that our variable is on the left. So if the arrow is pointing to the right, this is a greater than sign. And there's no line under it, so it's just greater than. If it points to the right with a line under it, that's when it's greater than or equal. So these are things that we've had written down in the past. Similarly, if the inequality is pointing to the left with no line, it is a less than symbol. And if the line is underneath it, it is a less than or equal symbol. So if we have sentences that use those words, we can take the words out of the sentence and replace them with these symbols. Sort of like the word is, when we're talking about a word problem, represents an equal sign. These words represent these symbols. There are a few other symbols that I need us to know, though. Some of them are intuitive and some of them are not. For example, if you don't see the words greater than, but you see the words more than, that's a synonym, and so we're going to be able to replace those words with a greater than symbol. The two that are not quite as intuitive and take a little bit of thought to understand are at least and at most. The most confusing part about this is when I say at least, we always think small, 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 it's got to be less than. However, it's actually the opposite. When we have the words at least, that's a greater than or equal to. And the words at most is a less than or equal to. Those are very difficult to remember. Now, why do we consider those? I always try to bring it back to money because that helps me understand things a little bit better. If your bank account has at least $100 in that bank account, think about what that means. Does that mean you have less than $100 or more than $100? Hopefully you recognize if you have at least $100, that means you have $100 or more. That's a greater than or equal to. So the use of the word at least is very confusing, sort of like the use of the words less than when we are talking about subtraction can be confusing. 2 less than 5 is not 2 minus 5, but 5 minus 2. So it's sort of the opposite there as well. So let's go ahead and I want you guys to try numbers 1 through 6. Press pause and write an inequality. In fact, I'll do number 1 with you. X is at most. Again, the word bank, at most, is a less than or equal to sign. So I have X at most is less than or equal to 9. Done. There's my inequality. Try to do the same using your word bank to answer numbers 2 through 6. Press pause, try it, unpause to check your answers. So as you can see, I have it set up where I just know I have the variable and the number in there, and it's just a matter of which symbol. At least, or is at less than, it should just say is less than, is just a simple less than symbol. At least means it's greater than or equal to. Greater than is just greater than. I'm going to skip 5 and come back to it. At least is another at least, greater than or equal to. This one I tried to make it a little tricky. Put this word no in there. No more than 25. So I don't have that in the word bank. I just wanted to see if anybody would get it. If you bring this back to money and you say your bank account has no more than $25 in it, that means it doesn't have that much. It has less than that, or equal to, because it's not more than, and 25 is not more than 25. So those are just the application of those words, some real life situations where we can write an inequality to represent a real situation. In a school zone, cars can drive at most 20 miles per hour. So we would say that they can drive d, or any variable we want, at most less than or equal to 20 miles per hour. So we can represent that real situation with an inequality. And we just had a president sworn into office, and that person was voted in. You must be at least 18 years old to vote. So your age needs to be greater than or equal to 18. School's right down the street from Six Flags. A lot of the roller coasters have restrictions on height. You have to be a certain height in order to ride the roller coaster. An example might be you must be more than 4 feet to ride the roller coaster. That means your height needs to be greater than 4 feet. So these are all inequalities that are out there that we see on a daily basis. We don't always represent them with these symbols, but we can. On the back of our notes, we're just revisiting inequalities. We looked earlier in the chapter at just saying, hey, x is bigger than 5. Is 5 a solution? We didn't look at it when we didn't have it solved for x already. Now that we can solve this for x, we can answer that. But we can really answer it two ways. I could solve this for x, divide both sides by 2, and get x is greater than 4. And now just look for the number that's greater than 4. The second option to solve these problems would be to just plug these in. 4x each time. 2 times 2 is 4. And ask ourselves, is 4 greater than 8? No, so that's not a solution. 2 times 4, I get 8. Is 8 greater than 8? A lot of people would put this as our answer, and it is not right. 8 is not greater than 8. There's no equal sign underneath this. 4 does not work because it's an inequality, not an equation. 2 times 7, however, is 14. 14 is greater than 8. That's a solution. The other way we looked at that, we had x equals 4, or x is greater than 4. 2 is not greater than 4. 4 is not greater than 4. It's equal to. 7 is greater than 4. That's my only solution. So if I asked you to determine if this is a solution to this inequality, we can do it in one of two ways. Solve the inequality, or substitute this into the inequality and check if the answer is accurate. I can check if 7 times negative 2 minus 10, negative 14 minus 10, or negative 24 is less than negative 22. Now, negatives are not easy. Think of a number line though. On a number line, if this is 0 and I move to the left, I'm going to get to negative 22 before I get to negative 24. So is this number here greater than or less than this number? It is less than. Even though 24 and 22, we're not looking at that. Because they're negative, it's less than since it's further to the left. So yes, negative 2 is a solution. And explanation could really just be my work here. There's my explanation as to why.